Hi, welcome to this video. We are continuing with our series of sample questions from the SOA website for exam FAMS. Okay, this is question number 9. Those of you who have been with me for some time will see that we have done this problem in class in our lecture. Let's just go through it real quickly. This is you're given. Let's read the question. You are given losses follow an exponential distribution with mean theta. Okay. And what I did was I wrote down the CDF of the exponential distribution beside it, right? And this you can easily, if you don't remember this, you can get this easily from the tables. And then they give you some data in group form. A random sample of 20 losses is distributed. A loss range 0 to 1,000. I have a frequency of 7, and I have got 6 claims in the 1,000 to 2,000 range, and I've got 7 claims in the 2,000 and above range. Okay, great. So the important things, I have my frequency here, which is my number of observations. That's good. And then I have my probabilities here, which I will get from, let's say I'll use f of 1,000 minus f of 0, right? And this one here is 0. So that's pretty good. So for the first class, 0 to 1,000, we have this probability. Okay, probability that x is less than or equal to 1,000. And then for this one here, we will be looking at the CDF F2000 minus F of 1,000. Okay. And finally here, we'll be looking at F of infinity minus F of 2,000. Again, I'm not saying much about F. I think you should know by now I'm talking about the CDF. And F of infinity is 1. So I have, for the last group here, I have 1 minus F of 2,000, which will serve as my probability. And the frequencies are all given. So for us, we can set up the likelihood function straight away. So I have done it for you. Let's just go through it very quickly. Okay, so we have, hang on, okay. Let me just clear this, yeah? Okay. By the way, we asked to calculate the maximum likelihood estimate of theta. I did not read that part of the question out. But anyway, let's go ahead and set up the likelihood function. We have got, the first one will be, remember I wrote F1000, F1000 minus F0, that's 0. So I have F1000. And how many do we have? 7. Good. And for the second class, I have F2000 minus 1000. Okay, all raised to the power of 6. And finally, I have 1 minus f of 2,000, all raised to the power of 7. Okay, this is raised to the power of 7. Okay, so that's your likelihood function. Basically, you need to plug in, right? Remember I said it's 1 minus e to the power minus 1 over theta x. That's my CDF. So plug in x. The first one is 1,000. So I have this thing here, raised to the power of 7. And then you just do the same, right? For f of 2,000, f of 1,000, and so on, and you'll get all these things out. Okay. When you take one minus the other, you'll get e to the power minus 1,000 over theta minus this. And then we have this part here, which is e to the power minus 2,000 over theta. Great. Note, this is raised to the power 7, this is raised to the power 6, and this is raised to the power 7. So once you're done with that, we need to clean up a little bit. Okay, so I can... okay, we need to clean up the algebra a little bit to make it a bit easier. So basically, I've left this alone. You can see that here. Okay, this one here, okay, I've taken out e to the power minus 1,000 over theta. So this thing becomes 1 minus e to the power minus 1,000 over theta. Remember, this was all raised to the power of 6, right? So this is 6. So when you clean up the indices, okay, you'll get this. Okay, e to the power minus 1,000 over theta raised to the power 6. And then this thing here, which is raised to the power 6. Okay, just some minor algebra. So now you can marry this up. Okay, So let me just erase this. Okay. So we can leave this alone first. Okay. No, I've done this part, right? I've done this part, so that's pretty good. So you can see this is 7. 1 minus e to the power of minus 1000 over theta raised to 7. This one here is 6. So 7 plus 6 becomes 13, taken care of. Then I have this term here raised to the power of 6. This is raised to the power of 14. So I have 14 plus 6, 20. I have this thing here. Okay. So we're almost done. This is the likelihood function. So I've written something here, which is your, to give you, just to remind you of something, the Bernoulli idea. Some time ago, we talked about an idea like this, right? We have theta A and 1 minus theta to the power of B. And then we called upon the Bernoulli idea to come up with the uh, maximum likelihood estimate as A over A plus B, right? Okay, so go and look it up if you've forgotten. Okay, go and look it up if you've forgotten. Not a big idea. Can you see this is just like this is A and this is one, not, excuse me. This is theta and this 1 minus theta, right? So we can think of it as like this, theta A, and this is 1 minus theta. Sorry, there are too many thetas around. Just forgive me for that. If you want, you can call it alpha, right? And this will be B, right? This will be, if you want, you can call it alpha. Alpha raised to A, 1 minus alpha raised to B. That's basically, this is the way that I taught it in class, remember? So if you want, you can take logs and yeah, take logs and do all those. But if you can remember the idea straight away, you know it'll just be your A over A plus B, right? So it'll be 20 over 20 plus 13. But look, this is not theta though. Yeah, this is not theta. This is what? E to the power of minus 1000 over theta. So E to the power of minus 1000 over theta is 20 over 33. So you can go ahead and use a calculator. Okay, you can go and use a calculator. Okay, I'm talking about this line, right? This line here, uh, take logs first. Then you have minus 1000 over theta is log of this. And then when you plug in the numbers, you'll get theta is 1996.903. So I'll give you an answer of B. Okay, thank you for watching.